Dear students, today we'll start with a very important chapter, that is electricity, which is required for you in your class 10. Before going into details about this chapter, let us first simply understand what is exactly electricity, what is the essential of studying in so much details. See, our life has become totally dependent on electricity. Starting from the morning that we get up till we go to the bed, the devices that we use are totally directly or indirectly related to electricity. The mobile phones that you're using are charged with the help of electricity. No doubt there is a battery or standby backup, but still it's charged with electrons. That is electricity. The fans that we switch on, the ACs that we are using, the lift that is required to lift up in the tall buildings, then you see all around whatever activities you're using a computers, using of other machines, using a washing machine, so many equipments that we are using or devices that we are using are dependent on electricity. Therefore, electricity plays a very vital role in our everyday life. Now, for your class 10, you require this chapter. And why is it so much detail studied? If your concept of electricity in class 10 is clear, it will be very, very easy for you in class 12, class 11 to understand the real details about electricity. Because if the fundamentals are clear, if the bases are clear, later on it will be very easy for you. Now, to be precise, what is electricity? Now, electricity is divided into two basic types. One we call it static. The other one we call it electric current. For your chapter, electric current is required for class 10. This is not required, but just for our understanding, static electricity is the electricity at rest. That means the electrons from here do not flow. But if we talk about electric current, there is a constant flow of electron. Therefore, the word current is being used, flow. Electricity that flows is called electric current. Electricity that is at rest, we call it static electricity. Now, the word electric or the word electricity has been derived from a Greek word which is known as E-L-E-C-T-A-R-O-N, electron. This particular word is not exactly electron. You will be surprised to know it is talking about amber, A-M-B-E-R. Electra means amber. So this was just information about the word derivation, from where the word has been derived, electricity. Now, to understand electricity, we have to understand this flow of electron. Now, when we say flow of electron, why will an electron flow? What makes the electron flow? Why and where does the electron flow? To understand this, we have to understand the word that is charge. What is charge? We have understood in previous classes or previous chapters. Charges are of two types, positive and negative. But let me be very clear with you. We'll come in details about this charge once we deal it. Then only I'll come to the word charge and much more in details. Now, let us assume, to understand it better, let us assume just a metal piece. For example, I take sodium, whose atomic number is 11. If you break the electronic configuration, 2, 8, 1. Now we understand that atoms of these solid are very closely packed. Very closely packed, therefore they are called rigid. Now, how many of atoms are there right now in this? I have no idea. Just imagine a metal piece. Now, metals we know are very good conductor of electricity. That will come a little bit later. Now, just imagine this atom. 1, 2, 3, 4. I'm just counting it. It may not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I've just taken 15. Suppose in this metal there are 100 atoms. I have just assumed 100 atoms are there. Now in this room temperature, for us to lose electron is very difficult. But for a metal like sodium, whose outermost shell has one electron, this room temperature is sufficient enough for it to release that electron. Sufficient enough to release this electron. Now, if the electrons are released, by the atom, this particular atoms become positively charged. By losing electron, they become positive charge. But to understand, these electrons have come out of the atom, but they have not gone out of the metal. That means they are still within this metal. Only they have become very naughty. Simple way to understand. Very naughty. They are just moving around here and there, but they have not left the metal. That means it could be like naughty children. They are doing all sort of disturbance within the house, but they are not gone out of the house. They are doing all sort of mischiefs within the house, but they are not gone out of the house. That means that we are talking about, assuming it to be 25 degrees centigrade. The electrons have just come out of the atom and they are moving around. They are moving about haphazardly. Here and there, all directions they are moving, but they are moving within the metal. At this juncture, these electrons, while they move haphazardly, they either dash each other. Either they could dash each other, or they dash the parent atom from which they have come up. They dash each other from the parent atom which they have come up. And there is a huge number of electrons moving around in this place. So Einstein once told that there are this state that we call free electron state. This free electron state within the metal, Einstein told it's like an ocean of electrons. Now just to understand, or just to get an idea of, if we take 1 cubic meter of a particular metal, suppose we assume a 1 cubic meter of any metal, how many free electrons could be there? It is estimated by the calculation as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. This many zeros are there. You have to be very good in math to talk about what is it. It could be known trillion, crores, triple trillion, billions, I have no idea about it. We have to count and see. I don't have the idea. I don't know the sum of the ideas. But to be precise, in 1 cubic meter of a metal, there is 10 to the power 27 number of electrons. Such is the huge number of electrons that we call as what? Pool we call it. Therefore, we call this one as free electron pool. Now, what is free electron? I'll be defining it. I'll give you the definition. Now, this part, I hope so is it clear. If you want me, I can repeat once again. If you imagine a metal at the very room temperature, the electrons are so loosely packed that they jump out of the atom and they start moving within the metal in a haphazard manner, hitting each other or hitting the parent atom. That state we call it as a free electron. This could be because of any reason. This could be because of temperature, because of heat, because of rubbing. It could be anything. Now, if suppose you have applied heat, or if you have applied friction, you have applied light, any energy, so that one electron jumps out of the metal. One electron has jumped out of the metal. Now, what is the charge of this body? Since it has lost one electron, what this body will be now? It will be positively charged. Positively charged, because there is deficit of electron and there is extra proton out here. Deficit of electron results in positive charge. Now, if this had not taken place, you have not applied heat, did not apply friction, all electrons are freely moving inside without going out of the metal. What is the charge of the body? 0. Since the number of electrons and number of protons are still same, because they are still bound with some sort of electrostatic force of attraction which is not allowing the electrons to go out. Therefore, it is net 0. But the moment you apply heat, the moment you apply friction, number of electrons moving out. If it is 1 electron, it is positively charged. 2 electrons, double positively charged, twice positive charge. It carries on. Now this happens because of 2 reasons. It could be applying of heat, you are applying friction, or you are applying light, because light is a form of energy. There is quantum quantity of photon coming in, billions of photons coming inside a particular object, and the electrons may jump out of it, making this body positively charged. Is the point clear? Next, after this, we will be going to the next part of it. How can we charge this body positive, or how can we charge the body negatively?